Driving the Naviers equation of a homogeneous isotropic body, or determining the distribution of a stress and the displacement in the interior of an elastic body in equilibrium when the body force are prescribed and the displacement of the points on the surface of the body are prescribed by the function. First of all, we shall obtaining the equations in terms of the displacement ui by substituting the stress in terms of the displacement in equation of equilibrium. Since we know stress-strain relationship in torque, which is tau ij is equal to lambda delta ij v plus 2 mu e ij, where ij is 1, ij equal to 1 to 3. Now differentiating the with respect to j, we getting with respect to j, tau ij j is equal to lambda delta ij vj plus tau 2 mu e ij j. Now since we know e ij is equal to 1.5 u ij plus uji, now putting I equal to j, ejj is equal to 1.5 ujj plus ujj, which is equal to 2 ujj. 2 से 2 cancel हो जाए, by cancelling 2 to 2 we getting ujj, and so we have v is equal to ejj is equal to ujj, which implies vi is equal to ujij. Since ij is equal to ji, so in this relationship we getting vi is equal to uji. Now our this particular equation we writing tau ij is equal to lambda delta vj plus 2eij. In place of eij differentiating with respect to j, we getting 1.5 to ij j differentiating plus 2ji differentiating with respect to j. First part, then second part. So tau ij is, which implies tau ij is equal to lambda delta ij vj plus 2 mu del square mu I plus uvi. Therefore the equation of equilibrium, as we know, torque plus force is equal to 0, so equation becomes delta lambda delta v ij vj plus mu del square ui plus mu vi plus fi is equal to 0, which is equal to lambda vi plus mu del square ui plus mu vi plus fi is equal to 0, or lambda vi and mu vi we taking common, so we have or u mu del square ui plus lambda plus mu I, differentiation of v with respect to xi plus fi is equal to 0, where v is equal to ei ui or divergence of u. These are called as the Naviers equations. Here we shall take the compatibility equations to impose the restrictions on the restriction on the strain components, so that the given single valued continuous displacement ui when the region T is simply connected. The given problem is completely solvable if we obtain the solution of the system of one subject to the boundary conditions. The ui is equal to fi x1 x2 x3, I is 1 2 3. Here fi is the prescribed continuous functions on the boundary of the deformed solid. Knowing the ui from one stress strain can be determined.